So, question number 6, we're plotting the velocity of a body after a certain instant is given by this function. A graph of the function is shown here. We're plotting velocity against time. If you remember, integration allows us to find the area underneath the curve, and the question is asking us to evaluate the integral between 0 and 2. So actually, I'm after the area between 0 and 2. This area here. On top of that, we might be asked to consider what this represents. The integral of velocity against time, the area under a velocity time curve, velocity times time, is actually the distance travelled. It's not asking you to say that in this question, but that represents the distance travelled by the object. It's first of all travelling one way, and that's this area underneath here, and then it's going back the other way, so we can end up with finding out its actual displacement from some arbitrary 0 at a given between 2 points in time, between 0 and 2. So that's what you're after, this area underneath the curve, and this is what we're asked to do in words, or in symbols rather. Evaluate this integral. So we do the integral, and then we put the limits in. Work out what the integral using your table of standard integrals, and then put the limits in, the 2 first and then the 0, and try and calculate the area. So I'll just pause this video for a second and see if you can work that out. Okay, so first step, the integral is add 1 to the power, so that's 2t cubed over 3 plus 3t squared over 2 minus 5t. Because the t reappears. We don't bother to put the c in when we're working out a definite integral like this, because the c disappears. Between the limits 2 and 0, so that's the first thing I'd write down. I can't simplify this particularly, so that's how I'd leave it. And now I've got to put the values in, so see if you can carry on and finish that off from there. Remember the convention, using curly brackets, and I'll be looking for that sort of convention. 2 times 2 cubed over 3 plus 3 times 2 squared over 2 minus 5 times 2 is the first limit, and I think you don't need to go mad on the second one, because if t is 0, the whole lot's 0, so that's perfectly acceptable. So final answer, 4/3, and remember what that is. That's the area under the curve, which might well represent the total distance travelled, because we've got a velocity time graph here. So this is actually not distance, it's the displacement. So that's the final displacement of the object, 4/3 from its original start point in 2 seconds.